Hi everyone, this is Manmeet Singh, and I'm going to give a presentation on botnet detection. So let's start. So we'll have a very brief agenda. We'll start with introduction, then history of botnet, life cycle, what's the architecture, current statistics. Then we'll followed by literature survey. Then we move on to future work and followed with references. Now let's start. What is botnet and why are we studying this phenomenon? So botnet basically is a network of compromised hosts, which is remotely controlled by bot master. Communication happens via command and control server. Now this botnet is a platform which is used to launch various nefarious activities like DDoS, click fraud, ad fraud, ransomware, spywares. So it can be said that this is botnet basically comprises of bot. Bot is a kind of a malware which has the capability to communicate with command and control server. So now this picture gives an overview of what botnet is. As we can see here, there are a lot of bots which basically comprise of machines which are compromised, and now there's a bot master which set up a command and control server, and this command and control server is used to communicate with the bot and is used to launch various attacks. Now, if you see the history of botnet, it started as early as 1993, and Eggbot is considered to be the first bot network, and it mainly used of IRC. It was centralized architecture. We'll see as we move on. IRC basically stands for Internet Relay Chat, and it's a protocol wherein a lot of hosts can join a conversation and can send chat messages. However, this was compromised, wherein a bot master could send commands, and those commands are executed by all the recipient in the network. Now, it was followed by in 1998 by GTBot, EgoBot in 2007. Zeus, struck, and it's still considered one of the most destructive botnet, as it lead to a lot of financial losses, and a lot of other bot you may have seen if you are in this domain. For example, Conflicker is still around. It has 10 million users. Now let's move on to the life cycle. So it starts with the setup of the infrastructure, which is followed by the basic infection, and then downloading of bot binary. Now what happens is the postmaster who need to create a botnet first have to create an infrastructure wherein all the bots or the machines would reach out once they are when they are done with the installation. So what basically happens is he sets up a CNC server and all those prerequisites. Then basic information maybe from your pen drive or from email attachment or some kind of a share error in the share, which leads to bot infection. Once basic infection is done, it loads a binary which basically infects the system with the bot, and then this infection leads to communication with the CNC server. That's basically the rallying stage in which a bot reaches out to its CNC server, and then it executes a command which is received via the communication, and it's a continuous process in the sense that a bot needs to upgrade to latest binary so that it doesn't get detected by antiviruses and other security mechanism. And moreover, there's a continuous maintenance again wherein new payload and attack vectors are added. Now basically there are three architectures: centralized, decentralized, and hybrid. In centralized there is center point that is HTTP based or IRC based. Decentralized basically makes use of peer-to-peer. So this can be seen while using this diagram. It basically depicts that both have a single point of communication, and that is through CNC server, and which is maintained by the bot master. So bot master has direct access to all the bots in the network. Now let's come to decentralized or peer-to-peer network. In this there is no direct communication between all the bots to the bot master. A bot master typically deals with only few bots, which in turn send those messages to all the members in the bot, as typically it happens in peer-to-peer network. Now let's start the current statistics in botnet. As we can see, botnet is still around. This report is published by McAfee Labs 2016. Okay, so Pomi and Sality, Darkness, Ramnet, these are very popular botnet and they are still around. Let's come to top 7 most botnet effective countries, and you will be surprised that India ranked number 1, which is a very serious concern. Uh, as we can say, 18,065,438 infected machines reside in India, and these are statistics of 17 May 2016. This report is released by Spam House. Now let's start the detection technique, and why detection is still is a complex thing. Now botnet, as I told you, can be detection techniques can be broadly classified into signature based and anomaly based. Signature based make use of signature or voice definition. Anomaly based make use of deviation in the generic behavior. We can further classify into host based and network based. Host based relate to deviation in the host procedure, where network based deals with anomaly that arises in the network traffic. It can be active or passive. In active, we send some probes, which is further checked for responses, like we do in case of voice fingerprinting. In case of passive, what we do is we take out the traffic dump and then we analyze. This passive analysis can be further classified in application based and protocol based. Application based, for example, we are looking for IRC traffic only, so or some peer-to-peer traffic only, so those application based we can do. In case of protocol based, we make use of IRC, HTTP, or some DNS. For example, how many requests are being sent from DNS to a DNS server, and what are the replies and the deviation in the normal system. For example, a normal PC may not send a lot of requests, but a system infected bot may send 10,000 requests per minute, which is very strange. Now let's come to literature survey. So the first DNS based detection started as early as 2005 by Anirudh, and they make use of DNS based black hole lists for counterintelligence. Then in 2006, Taylor and al. Produced a detection technique which makes use of traffic flow characteristics like bandwidth, duration, and packet timing. It was followed by Bot Hunter in 2007. It's a very effective kind of a tool wherein we can find an infected machine using correlation engine. Then Wilmer, Silman et al. Presented DNS traffic based anomaly detection. Again 2009, Berdesky produced a novel approach for passive analysis. Zheng et al. Produces how to find suspicious activities in the network using a DNS failure graph. Then Cho et al. Presented a very interesting paper on Botnet group analysis detector, and it has a framework wherein they group in the hosts which have similar kind of queries. Now Yadav et al. Presented another detection technique which based on the number of failed DNS queries. That is, their logic is based in the sense that a system which is connecting to the internet may not send lot of queries which do not exist, which is typically being sent by domain generation algorithms based bots. So Gintu et al. Presented a bot infected machine using comparable supported DNS queries. Then Reza et al. 2015 presented technique which makes use of the fact that the names generated by an algorithm are quite different to the real world domain names. Then Hans et al. Analyzed the malicious use of DNS by cybercriminal and potential hits. Then Neng et al. Presented method again for detecting names generated by a generic and by the domain name generation algorithm. So let's have a view on future work. So as shown by the statistics, bot still is a threat. It's a continuous threat and it is evolving. Anomaly based detection system have performed better to combat this threat. Signature based or blacklisting or maintaining a list doesn't make sense because new domains are added every day, so we cannot blacklist all the new domains because we are not quite sure. The DNS protocol used by all the bots to communicate with NCA server. So future is a lot of future on how are the various anomalies in DNS based on detection system. These are some of the references, and that's all. Thank you. Thanks for watching this video.